Welcome to another unit in the workbook Statistics. This time I'm going to talk about exponential smoothing. With exponential smoothing we can differentiate between 3 degrees or orders of exponential smoothing. In the first degree we are only considering a level component, something like an intercept from a function. In a second degree exponential smoothing we're considering the level and the trend. So we assume that the data follows something like a linear function. Then in a third degree we have the level, the trend, and a seasonal component. So we assume that there's a pattern which repeats after a certain amount of periods. Well, especially the third one is relatively complex, especially regarding how this seasonal component is introduced. So here we're going to restrict ourselves on the first 2 degrees. I'm going to start with exponential of the first degree, exponential smoothing of the first degree. Well, the idea behind exponential smoothing is, we can see this very good on this function already. We're considering current values, but we also consider past values. But the past values decrease in importance exponentially. So even the distant past might have a very, very slight impact on our estimate for the current period, but only a very slight impact. The more recent values, the more recent estimates are much more important. Well, here we just see the current period, the value from the current period, and the estimated value from the last period. And this alpha tells us how much each of these 2 parts matters. If we have a large alpha, the current value matters much more, the past matters less. So a large alpha means we smooth less. However, if I have a small alpha, I would smooth more because I would put more emphasis on past values. Well, here we just see 1 period into the past, but well, this was an estimate as well, so we could replace this one with the estimate from the previous iteration as well. And we see here at this point we have the value today, the value last period, and the estimate from 2 periods back. And we have this parameter once, twice for this value. And this increases for each period I'm going to go back. Well, this is smaller than 1, so the impact decreases all the time the further back I go, and it decreases exponentially, but it's still important. So well, that's the general idea behind the exponential smoothing, but well, you might gather I have the problem, I have to have 1 starting value, 1 initial value, and here we're going to make this very easy. We just say the first value is just the first initial value. So no estimation in any which way here. Well, this works decently well. This regards for some trend components. So this gives us a first estimate if we continue with this. But a little bit better would be exponential smoothing of the second degree. That's what we're going to explain next. Here it's not as easy to understand what is happening because first off we need these 2 help factors, and they look similar to what we know from this part here because each of them is smoothed by itself. First off we take the original value and this smoothed value from the previous period, and this one is related, as we can see here, to this smoothed second help parameter. So that's why it's more or less smoothed twice in this regard. If we consider the end result, it looks like this. Might be a bit confusing, but we can determine there's this level component and there's this trend component. Why this is the level, this is the trend component, would go into more details, but we can actually say this describes more or less on which level we are, what more or less the intercept of this underlying function would be. This is the trend describing how steep the increase would be or decrease would be. Well, that's then already everything there is I wanted to mention regarding exponential smoothing of first and second degree. I hope you enjoyed this short session. I say goodbye and see you next time.